Okay, so now we are looking at Kramer's rule from this website. Okay, it's quite a good website. I will give you the link in the Putra if you want to read more by yourself. Okay, so they were talking about we are going to solve that simultaneous equation using Kramer's rule. So Kramer's rule is also known as the determinant method. Okay, so you can read this yourself. I just want to show you this one here, Kramer's rule 2 by 2, which is what we have just now since we have a simultaneous equation. So Kramer's rule for the 2 by 2 matrix is applied to solve the system of equations in two variables. Okay, let us consider two linear equations in two variables, a1x plus b1y plus c equals to c1, a2x plus b2y equals to c2. Okay, so essentially this is the same as the equation we have just now. The only difference is the coefficients is no different. The difference is the variable here, which is used x and y, whereas in the equation just now it is x1 and x2 here. So you can see here 2.118a and 2.118b. So it is the same configuration of a simultaneous equation where x1s is one of the variables and the other one is the x2s. Okay, so essentially in the Kramer's rule example, x1s is a and x2s is x1s is x and x2s is y. Okay, so once you have the equation in this form, you can put it in the form of a matrix, which is ax equals to b. Okay, if you remember matrix, this is how you can rewrite it. And then you can where you put it in terms of ax equals to b, and then you can represent each matrix by a different name. Okay, coefficient matrix is a, the variable matrix is x, and the constant matrix is b. So D is the determinant, or in the normalized example they use delta, but it's the same thing. Okay, so to get D is the determinant of A. Okay, and the value for that is A1 times A2 minus B1, A1 times B2 minus A2 minus B1. Okay, and then you can also find determinant according to the variable. For determinant of x, you have the equation here, c1 b2 minus c2 b1, and for dy you have a1 c2 minus a2 c1. Okay, so we need to find, this is why you see here x equals to dx, or the determinant x over determinant, and y is equals to determinant y over determinant as a whole. So that is how you got this transfer function. From this, the transfer function x2 fs is, which is the determinant of x2 s over the determinant of everything. And so as you can see, delta here is represented as this matrix. Okay, it is not solved or anything, it's just put in the form of delta. Okay, so I think you need to get better understanding, you need to go through it and manually arrive to this conclusion of delta. Then you can see why that response is what it is. But it's basically applying Kramer's rule to two of the simultaneous equation that we obtained just now from the free body diagram. Okay.